Hello guys, welcome back to my channel. In this video we'll be talking about the concept of integration. Okay, and I will still solve my workbook that I have. Okay, so the first one we are going to solve is question number 53. Question number 53 and 54. So question number 53 said 53 said the integral of ln x dx. Okay, now you just need to know the answer. The answer for integration of ln x is x ln x plus a constant. You just need to know it. But let me show you how to solve it. If solving it, if you cannot solve it, just know that it is x ln x plus a constant. X ln x, then plus another x, sorry. X ln x plus x. Then you know that this plus a constant must always be there in every integration. So just know that it is what? X ln x plus x. X ln x plus x. So let us see how this is equal to the solution. We have that, do you believe me that integration of ln x multiplied by 1 dx, this is certain as this, okay? Hope you believe that. Ln x times 1 is still ln x. And then this is now product rule of integration, that is integration by parts. Now, in choosing integration by parts, sorry, the formula say that the integral of u dv is equal to uv minus the integral of v du. Okay? Now, this means that one of them is going to be u, and then the other one is going to be dv. But the problem is that we don't choose it anyhow. We don't just say that ln x is going to be u, and then 1 is going to be dv. No, we don't choose it like that. We use the formula that's called ladies like pets. Ladies like pets. Which shows that if we have logarithm, L means logarithm, polynomial, exponential, and trigonometric. So if logarithm is there, then logarithm is going to be the u. So this is the method to choose your u. So, and if you see here, you see that we're having ln is logarithm. So this means that our u is going to be that ln x. Why our dv will now be 1. Dv will now be 1. Okay? If you choose u, the remaining one becomes your dv. So if you look at this formula, we have 4 things. We have uv, du, and dv. So since I have u and dv, the only thing that is remaining is now v and du is remaining. So if I differentiate here, I'm going to have du is equal to 1 over x, because differentiation of ln x is 1 over x. Now, for me to get my v is to integrate both sides. Integration of this is v. Integration of this will give me x. Okay, so I have gotten everything. Let me now substitute it in this formula. I'm going to have the integral of u is what? Ln x dv is 1 dot 1 dx, which is the question, is equal to uv, u and v, which is what? X ln x minus okay, sorry, this is minus a, take minus a constant. Yes, it should be minus and not plus. Okay, so this is x ln x, then the integral of v du, v du, v du, okay, v du, which is what? X dot 1 over x dx. Okay, so this is now equal to what? X ln x minus the integral of 1 dx, because this cancel this is 1 dx. So which is what? X ln x minus integration of 1 is x, minus x, then plus a constant. So that is the answer. All right, so it is x ln x minus x, x ln x minus x, plus a constant is always there after integration. So the next question we'll be solving is question number 54. Question number 54 said the integration of e raised to power 3x plus 4 dx. Now, this is the easiest integration that you will meet in this calculus and coordinate geometry. Okay? Now, let me teach you something about e raised to power something. Now, if you have the differentiation of e raised to power, you want to differentiate e raised to power, maybe 3x plus 4. Okay? Now, the differentiation of e raised to power x is the same thing as e raised to power x. And the integration of e raised to power x is the same thing as e raised to power x. So what do you do here? Whenever it is not x that is here, if it is another thing, all you have to do is just, if you differentiate that thing, then attach it with the question. So differentiation of this thing is just 3. I will now attach it with the question, 3x plus 4. I get it. So differentiation of e raised to power sine x. What do we do? It's supposed to be e raised to power x. Since another thing is there, differentiation of sine x is what? Cos x. I will now attach it with the same question. That's all the answer. So, but in integration of this, if it is integration, what we do is after differentiating, instead of attaching it, we keep it at the denominator. So what we do here is repeat the question, 3x plus 4. Then differentiation of here is 3. Keep it at the denominator. Then put your constant. Very simple. So integration of e raised to power sine x dx is simply repeat the question e raised to power sine x. Now differentiation of sine x is cos x. Now put it at the denominator, cos x plus a constant. So anywhere you see integration of e raised to power something or differentiation of e raised to power something, rush it immediately because it is simple to do. Okay, it's very, very simple. Okay, but let me now show you the normal method of solving its solution. We will say let u be equal to that power, which is what? 3x plus 4. Okay, now du dx is equal to what? 3, right? Now let me make dx subject of the formula. This thing implies that my dx will now be equal to du over 3. Am I correct? Yes. This one can go here, this one come here. Now let us substitute here. We have the integration of e raised to power. Instead of writing this person, I'll put it as u. So u. Now, instead of writing the x, I'll put that the x is what? Du over 3. Okay? Which is the same thing as 1 over 3 is a constant. If I bring out that 1 over 3 that is a constant, I'm having the integral of e raised to power u du, which is what? 1 over 3. Integration of e raised to power something is e raised to power that thing. It doesn't change as far as it is with respect to that same thing. Okay? Plus a constant. Now, what is your u? 1 over 3 e raised to power. What is my u? My u is what? 3x plus 4, then plus a constant. This is the same thing as this. Instead of writing this like this, we can write it as 1 over 3 e raised to power 3x plus 4, then plus a constant. You see? The same method. So the easiest thing you do is what? Differentiate this place, keep it at the denominator, repeat the question. Very simple. Repeat the question, differentiate this and write it at the denominator. Repeat the question, differentiate this, write it at the denominator. That is about integration of exponential. It must be exponential, that e, it must be that e. Okay, the next question for integration is question number 67. Question number 67. And question number 67 said, question number 67 said the integration of 4x raised to power 4x raised to power 4 minus 4x raised to power 3 all over 4 over 5x raised to power 5 minus x raised to power 4, then plus 6, the x. Now, let me show you the shortcut to quotient integration. Now, any integration that has fraction, the first thing you check is that if I differentiate this denominator, am I going to get the numerator? If yes, if you differentiate the denominator and you are getting exactly what is in the numerator, your answer is simply laying that same thing that is in the denominator. Then you now put plus a constant. Don't forget that you must put plus a constant. You see, differentiation of this is giving us this. That is why my answer is just laying that denominator. That's just the answer. But let me show you how to solve it in case you want to use the normal method. Okay? Now, once you notice that if you differentiate the denominator, you are getting the numerator, you will say let u be that denominator. That is 4 over 5 x raised to the power 5 minus x raised to the power 4 plus 6. Now, the x will now be equal to, multiply by the power, you are going to have 4x raised to the power 4. Remove 1 from the power, right? Multiply by the power, remove 1 from the power, you have 4x raised to the power 3. Differentiation of a constant is 0. Okay? Now, make the x subject. If I make the x subject, it's going to be what? Du over 4x raised to the power 4 minus 4x raised to the power 3. All right? Go back to your integration. This is now the integral of 4x raised to the power 4 minus 4x raised to the power 3 all over. We have called this man u, right? Instead of writing the x, we call it what? The x is something as what? The u over that same 4x raised to the power 4 minus 4x raised to the power 3. Okay? Now, this denominator cancel denominator. I'm having that this is the integral of 1 over u du. An integration of 1 over something is what? Ln that same thing, ln u plus a constant. Now, what is your u? Your u is that denominator. So, which will give you back this answer. Ln this plus a constant. So, instead of using this long method, differentiate the denominator. If you get the numerator as your answer. Hello? Hello? That is making noise. So, if you differentiate the denominator and you are getting the numerator, your answer is simply ln that denominator plus a constant. All right? So, we'll go to the next question. Question number 77 for integration. So, question number 77 for integration said that the integral of the x all over 36 plus 9x squared. Okay? Now, whenever you have this type of integration where this is called trigonometric integration, okay, inverse trigonometric function for integration. Now, I want to show you 3 important ones. They assist in number, but I'm going to show you the 3 important ones you need to know. All right. So they are, the first one is that the integration, just know this, the integration of 1 over the square root of 1 over the square root of a squared minus bx all squared dx is equal to, now, okay, now is equal to, now if it is positive here, it's going to be sine inverse of x. That is the answer. Sorry, sine inverse, sorry, before the sine inverse, we have 1 over b. First of all, 1 over b, then sine inverse of what? A of bx over a, sorry, bx over a, then plus a constant. Now, for cos is the integral of, this place become minus 1 all over the square root of a squared minus bx all squared dx, which is same as what? The same thing again, 1 over b, but now cos inverse of bx over a, then plus a constant. Now, the next one is now the integral of 1 over a squared plus bx all squared dx is equal to 1 over ab, the tan inverse of bx over a plus a constant. So these are the 3 measures that are very, very important. Now, the question is, how do you remember this? Let me show you how to remember it. Watch, we have the integral of, watch me, 1 over is always a squared if it is minus bx all squared. If it is minus shows that they must be covered by square root. And if they are covered by square root, you have the x if you like. They can just put the x here because 1 times anything is the same thing, depending on how you want your own to be. Now, if here is positive, it becomes sine. So sine inverse, or before the sine inverse, we always have 1 over b, please. 1 over b, then sine inverse of that bx over a. Okay? Bx over a plus a constant. Now, we have the integral of minus 1. Because of this minus shows that it's going to be cos. And I'm going to have a squared minus bx all squared. Because of this minus, it must be covered with square root. So the x. So this is equal to, because of this minus is why I'm having 1 over b again. Then cos inverse of bx over a. Then plus a constant. But in tan, there is no square root. So since there is no square root, here is going to be plus. So it's going to be 1 over a squared plus bx all squared dx, which is what? 1 over, instead of b, say 1 over ab, two of them. Then you have the same tan inverse of bx over a, then plus a constant. Why am I teaching you this? It's because of this particular question. Now watch. Do you believe me? We can write this question as the integral of 1 over 36 plus 9x squared, putting the x like this. This times 1 is the same thing. Do you believe me? We can still write it as the integral of 1 over 36 can be written as 6 squared plus 3 squared x squared dx. Okay? This is still what? The integral of 1 over 6 squared plus 3x all squared, okay, dx. So this is equal to, from here, my a is now 6, my b is now 3. So I have 1 over ab, that is 1 over 6 times 3. Then tan inverse of that 3x over 6, then plus a constant, which will give me 1 over 18 tan inverse of this into this will give me s over 2, right? S over 2, then plus a constant. So that is that's for that. Okay, we go to the next question, which is question number 79. Question number 79. Now, question number 79 said, question number 79 said, that we should integrate, is a definite integral from 1 to 3 of 5x raised to power 4 dx. Okay? Now, this is a very simple question. Forget about the boundary. Just let us integrate here. Don't forget that differentiation simply means you multiply by the power and remove 1 from the power. So integration is now opposite of it, which is add 1 to the power, divide by the new power. So let's say it together. Add 1 to the power, divide by the new power. So the integration of this is now 5x raised to power 4 plus 1 all over that same 4 plus 1. Then I have a boundary from 1 to 3. So this is what? 5x raised to power 5 over 5, boundary from 3 to 1. This can cancel this. So I have x raised to power 5, boundary from 3 to 1. This boundary means substitute the up first, minus substitute the down. Okay? So 3 raised to power 5, 3 raised to power 5 will give us 243. 243 minus 1. 1 raised to power 5 is 1, which will give us what? 242. You see? This is a very simple integration. Okay? We move to the next question. Question number what? We move to question number whatever. Okay? What question are we moving to? 93. Question number 93. And question number 93 said the integral of 2x all over x squared plus 9 dx. Like I told you before, that whenever you have quotient integration, the first thing you test is that If I differentiate the denominator, will I get the numerator? If yes, your answer is simply ln that denominator, okay, then plus a constant. Let's check. Now, but if you want to solve it normally, what do? We say let u be equal to that denominator x squared plus 9. So the u dx is equal to what? 2x. If I want to make the x subject, the x will now be what? The u over what? 2x. So you come back to this place. The integral of 2x all over. I have called this man u. Instead of writing the x, I will now write it as what? The u over what? 2x. You see that 2x will cancel 2x. I'm left with the integral of 1 over u du. And I told you the integral of 1 over this is what? Ln that same thing plus a constant. So substitute your u now. This is now ln. My u is x squared plus 9, then plus a constant. So instead of using all this formula, what you do is, if you differentiate the denominator and you are getting the numerator, your answer is simply ln that denominator. All right? So we go to the next question. That is question number 103. Question number 103 for integration. So question number 103 said, the integral of cos 3x ln 5x okay, sorry, that thing is sine 5x. Is a typographical error, so it is sine 5x, the x. Okay, now let me teach you one simple thing about the one that this type of integration. What we do is we apply the law of trigonometry. Okay, do you remember that sine a plus b is the same thing as saying sine a cos b plus sine b cos a? Okay, and sine a minus b is the same thing as saying sine a cos b minus sine b cos a. Now, if we now decide to add both sides, I'm going to have this plus this will give me sine a plus b plus sine a minus b is equal to, this plus this is gone, but this plus this will give me 2 sine a cos b, right? If I want to make this one subject, these two will come down. This one will now come down. I'm going to have that what? Sine a cos b is equal to 1 over 2 sine a plus b, okay, then plus sine what? A minus b, okay. So that is that. Now, if we are going to use this is now, watch me now, which means my a is 5x. So if I now want to integrate sine a cos b dx, will now be the integral of, so 1 over 2 the integral of everything here, okay. So which means that this thing, my a is equal to 5x, while my b is equal to what? My b is equal to 3x, okay, because sine is having my a and then cos is having my b. So this is now, the integration of this is now 1 over 2 the integral of, now let me use this, 1 over 2 the integral of sine a plus b, that is 5x plus 3x, okay, plus sine 5x minus 3x, then the x. So this is now 1 over 2 into, 1 over 2 into the integral of sine. This 2 is giving me 8x plus sine. This 2 is giving me 2x, okay, the x. So this is now 1 over 2 into the integration of sine is minus cos. So minus cos 8x over 8, okay, minus, this one is giving me again, minus cos 2x over what? Over 2, okay, then plus a constant. So finally, I'm having minus cos, okay, so that is that. So let's check the option. It depends on what we have at the option. So if you want to use this to multiply out, so it's going to be minus 8x over 16 minus cos 2x over 4, then plus a constant. So that is the answer for that. Okay. So the last question for integration, I'm rushing because I was told that my battery is low, so I need to change my phone. Okay, and charge the other one. So let us quickly solve question 104. Then we are done for integration. Question 104. Now, question 104 said, definite integral. So the integral from 1 to 5, sorry, from 1 to 3 of 5x raised power 4 plus x squared plus 1, then the x. Okay? So this is simple. What do we do? Normal differentiation. Add 1 to the power, divide by the new power. So this is now what? 5x raised power 5 over 5 plus x raised to power 3 over 3 plus x. And I'm moving from 3 to 1. So this is what? This cancel this. So 5 raised to power 3 plus x raised to power 3 over 3 plus x, then 3 and 1. So let us put 3 first, minus, you now put 1. So if I put 3, it's going to be 3 raised to power 5 plus 3 raised to power 3 over 3 plus 3. Okay? Then minus 1 raised to power 5 plus 1 raised to power 3 over 3 plus 1. Okay? So what I'm having here is 3 raised to power 5. 3 raised to power 5 is giving me 243. So 243, this is 27 divided by 3 is 9. Plus 9 plus 3, okay, minus, this is 1 plus 1 over 3 plus 1. So this is giving me plus 9 plus 3. So that is 255. So 255 minus, this is 1 plus 1 plus 1 over 3. 1 plus 1 plus 1 over 3. So I'm having 7 over 3. So 7 over 3. You see that the LCM is 3. So I have 255 times 3. I'm having 765 minus 7. So minus 7. I'm having 758 over 3. So if I divide by 3, I'm having 252 whole number 2 over 3. So that is that for that. Thank you very much for watching. Please, we love you, those that are supporting us by liking the video, sharing the video, and commenting. Bye bye. May the peace of the Lord be with you.